5 one tomorrow, and then if we do 2 days review, that pushes the test off on Monday into Tuesday. So I'm pleased with that. You what? Okay. Someone else said that was a problem.
No, it's a stats and calc business, but it's whatever.
Oh right.
Stats test is a quiz.
Oh my god.
Well, that does matter because if you do better on the test, it replaces.
Yeah.
Helps a little bit. Okay, so we're going back and looking at implicit differentiation and combining that with like increasing, decreasing, concave up, concave down, all that stuff. So it's a little different because you can't like make a number line with these because you have an explanation.
This might answer your question. I don't know any it. The movie. Little. The movie. Different having a number. The movie. Quote.
Alexa, what did you hear?
I heard. So it's a little different because you can't like make a number line.
Why did you answer?
I didn't know you could ask her what she thought you said.
Yeah.
I didn't know
Like I was watching The Office once and she started ordering something off Amazon. She's like, do you want to order this? I forgot what it was. And I was like, what did you hear? And then she played it back and it was a quote from that Michael said like in The Office. And, yeah. But I don't know why I didn't say her name before. Anyway. Okay, so we got this equation which has got x's and y's in it. We can't solve for y. So we have to use implicit differentiation to take the derivative of it. What does it say? Okay, so we gotta remember derivatives and implicit differentiation. So what's the derivative of 3x cubed? Is 9x squared. What's the derivative of 3? 0. The derivative of ln of whatever is 1 over the whatever. But then you multiply, that's chain rules, then you multiply by the derivative of the whatever. But then I took the derivative of a y, so what do I have to multiply by? Is that dy dx? You said dy dx, you either remember it or you watch the video. I'm pleased either way. And I want dy dx by itself. Because if dy dx is positive, what does that tell me the original graph is doing? Dy dx is derivative, right? So if the derivative is positive, we got positive slope, the original graph is increasing. If the derivative is negative, we've got negative slope, the original graph is decreasing. So, I got 2 options. I could solve for dy dx right now and get dy dx in terms of these variables and then plug in, or I could plug in right now. I think most people are more comfortable working with numbers than variables, so to me, you should plug in right away. It's kind of up to you. You might want to clean this piece up a little bit. So if I go like, okay, 9x squared equals, this would be 2 over y. Agree there? So 8 divided by 4 is 2, and then you got an extra y on the bottom. And then let's say I plug in, so I'll get 9 times negative 1 squared equals 2 divided by a half times dy dx. I don't even really care what the number is, but we can find this. So negative 1 squared is 1 times 9. And then 2 divided by a half, so if you, how many times does a half go into 2? 4 times. Or you can think about it as multiplied by the reciprocal. And then if I divide, I will get that dy dx equals 4/9. And again, I don't really care about the number. I care that it's positive because now I can say we are increasing since. Yeah, that's how much I didn't care about the number. I screwed it all up. My bad. Did that distract you from the point I was trying to do? So it's 9/4. But what I care about is it's positive. If the derivative is positive, that means my slope of the original is positive, and I'm increasing. So the original graph is increasing since dy dx is greater than 0. So same process as we did earlier, like just plug in the derivative, find out increasing or decreasing. This was like section 5.2, I think. It's been a while, but I'm just putting in, or they're just putting in implicit differentiation with it. didn't even ask me to justify, so I really could have just said increasing. But you mean like put like at negative one? Okay. I would say it depends on the way the question's phrased. Like if you're asked, at the point, tell me about the behavior at this point. I don't know. It all depending on the wording of the question. Like in this one, if you put this, you're totally fine. And even if I said justify on my test, if you put that, I'm fine. This is like kind of extra unnecessary, depending on the way it's phrased. Other questions on that first one? Okay. Second one, this has to do with 5-7 that we briefly discussed, but this will be good because we can discuss it a little bit more. So I get a point, equation, and then I'm asked about concavity. So what level does concavity come from? Concavity is the second derivative. So I got to take the derivative of this guy twice. So my first derivative would be 2x. 2x. The negative 3 derivative is 0, so it drops away. The derivative of e to the y is e to the y, but then you took the derivative of a thing with a y in it. So you multiply by dy dx. You guys kind of remember implicit differentiation? Okay. That's the first derivative. Well, it's not even yet. I can solve it. So I will get dy dx equals 2x over e to the y. So that's my first derivative. Questions there? Now we're reviewing quotient rule. It was good stuff. So now we're going to take the second derivative. So that's the derivative of the left-hand side is just, that just means like second derivative. Then I got to use quotient rule. So we use quotient rule as fig minus gif. So fig is the first thing. No. Fig is f prime, so it's the derivative of the first thing. Derivative of the top times the bottom minus gif, so g prime. So what's g prime? There we go. E to the y times dy dx. So that's your g prime, and then f is 2x. All over, what goes in the bottom quotient rule? The bottom squared, or g squared, so e to the y squared. So, question on that, on the quotient rule piece there? What I want to know is if this curve is concave up or concave down at that point. So what am I going to do with that point? Plug it in. I have the second derivative. If I plug it in and the second derivative is positive, that means concave up. The second derivative is negative, that means concave down. So let's plug it in. We will run into a slight stumbling block, but it's easy enough to fix. So 2e to the 0 minus e to the 0 times, and I'm going to come back to that, times 2 times negative 2 all over e to the 0 squared. Well, e to the 0 is 1, so that's helpful because it knocks out a lot of stuff. But I've got this dy dx. What's dy dx? Dy dx is this guy, right? So can't I plug that same point into this guy and figure out what dy dx is? So if I plug dy dx in here, I get 2 times negative 2 over e to the 0, which is negative 4 over 1. So then I can put a negative 4 in that spot. That makes sense what I did there? I regret not doing it in a different way. What? Yeah, it's got to be this way. So I'm going back over here to find out what dy dx actually is, and then sticking it in there. And then I'm just doing here. So remember, anything to the 0 power is 1. So 2 times 1, 2. And then this is 1 times negative 4. Negative 4 times negative 4, which is 16. And then that's 1 squared, which is 1. So at the end of all of this, I get a negative 14. So again, I don't really care about the number number that much. I care about what? That's negative, the sign of it. So at -2, 0, the curve is concave down. And if you were asked to justify it, you would say since the second derivative is negative. And if you want to get like more specific, you can say like at -2, 0, like what was asking. Okay, now? Questions? All right, 3. So they give us the derivative, and they give us the second derivative. And they're saying at 0, 1 is it a relative max, relative min, or neither. All right, well, if I have a relative max, right there is a relative max. There's two things that I know are true at that point. And we're gonna like check them both and see if they fit or not. Tell me any of the things, either of the things, both of the things. What's true at this point at the very top? Slope is 0, which means the derivative is 0, right? So dy dx. So this thing had better equal 0 if we're going to have a relative max or a relative min. What else do I know at that point? The second derivative is negative. How do I know that? Since this graph, if I have a relative max, it has to be curving downward. That would mean that we're concave down, and that would mean that my second derivative is negative. So those are the two things I have to check. The checking's not really the hard part. It's kind of coming up with this. Does that make sense why I'm going to check these two things? If it were a relative min, we would still want this to be 0, right? Because at the bottom that slope is 0. But we want the concavity to be up. We want it to be second derivative positive, so concave up. So let's check our facts here. So dy dx equals 2x times 3y squared minus 1. At this point, that means 2 times 0. That's good, the top is 0. So I get 0 over 2, which is 0. So that checks like the first box, but it doesn't necessarily mean it checks the second box. Let's check the second derivative. So the second derivative is, like, why? Why? You can very easily check if I understand what's going on without giving me 15,000 freaking things to plug into. Sorry, I'll stop. So I'm going to plug in. Squared times 1 over 3 times 1 squared minus 1 squared. Somebody say something that I put something wrong. No, over here, right? So this is 2 over 2 minus 0, so it's 1. So what I know about this point is the slope is 0. Since this is positive, we are concave up. If we've got a slope of 0 and concave up, what do we have? A min. Why did I start with a relative max? I think I thought it said like show that it's a relative max. But is it a relative max? No, it's relative min. So I don't know why I was doing this. I'm not sure. But I've got a slope of 0 and concave up. So don't have a relative min. Sorry about that. I think that still makes sense. Questions I can answer? We're at. It's work. Tomorrow 5-1, so do the notes for 5-1. Then I got we'll have a couple days of reviews. So Friday, Monday's review, and then test Tuesday. It works out better unless you're in stats. Stats is like a little bit clear. No big deal. stats, you mean?
Yeah.
Some people don't. Hopefully, people that hear. So let's. Okay. What about that negative one? Five, like 8 minus 5. 7.